Hi, in this chapter we are going to talk about recursion, so let's talk about a theoretical background. First of all, what is recursion? It is a method or procedure where the solution to a given problem depends on solutions to smaller instances of the same problem. So we break the task into smaller subtasks, and it is a quite common approach in computer science. For example, divide and conquer or dynamic programming does the same. The approach can be applied to many types of problems, and recursion is one of the central ideas of computer science. We have to define base cases, it's very important, in order to avoid infinite loops. And almost every problem can be solved with the help of either iteration or recursion. So for example, we want to add the first n numbers. Usually we use a simple for loop or while loop, but we can solve it with the help of recursive method calls. So that's why it is very important to see that almost every problem can be solved either with iteration or with recursion. With iteration, it is just a simple for cycle. With I equals to 1, I is less than n, which is going to add the result, increment the result by I, and of course return the result. As far as the recursion sum method is concerned, we have to define a base case in order to avoid infinite loops, as we have discussed. So the first line, the if n equals to 0, return 1, this is the base case. If n is equal to 0, we return 1. If we miss out this line, our code would run forever. It is going to call itself over and over again. And anyways, we just return n plus recursion sum n minus 1. So we are going to call the same method for a subproblem, not for n, but n minus 1. Okay, there are two main types of recursion, the head recursion and the tail recursion. If the recursive call occurs at the end of the method, it is called a tail recursion. The tail recursion is similar to a loop, so it is like a for loop and while cycle or whatsoever. The method executes all the statements before jumping into the next recursive call. So this is true for tail recursion. On the other hand, what about head recursion? If the recursive call occurs at the beginning of the method, it is called a head recursion. The method saves the state before jumping into the next recursive call. So that's the main difference between tail and head recursion. As you can see, we have to specify the base state, independent from whether it is a tail recursion or a head recursion. We always have to specify the base case. And the first line is this: if n is equal to 1, we just return. But it is the main difference. In the tail recursion, first of all, we just print out the n and then call the tail n minus 1. So we call the method recursively on a smaller subproblem. As for the head recursion, we are going to call the head and then print out the n. We are going to see a very small illustration with concrete implementation, and it will be clear. And it's very important that recursion and recursive method call has something to do with stacks. So we have to track during recursion who called the given method and what arguments are to be handed over. And we have to track the pending calls. We keep calling the same method over and over again. So it's a very important problem to solve. And we just need a single stack data structure. The operating system does everything for us. I assume that you have some knowledge about stack memory and heap memory. For example, local variables or method calls, method arguments are going to be stored on the stack memory. On the other hand, reference type objects or reference type variables such as objects are going to be stored on the heap memory. Heap memory is quite slow. On the other hand, stack memory is fast. But stack memory is smaller in size than the heap memory, and that's why with the help of recursion it is very easy to get stack overflow because we ran out of space. But with the help of this stack, and it is a data structure, not a data structure but whatever, it is an abstract data type because we usually implement it with the help of arrays, and arrays are the data structures. It's very important to be able to distinguish between data structures and abstract data types. Stack is an abstract data type, but we can solve this problem with the help of stacks. But we don't have to bother about all this. Why? Because the operating system is does everything for us. So these important informations are to be pushed to the stack, and values are popped from the stack. So let's see, when we use recursion sum integer n, for example, when we try to add the first n numbers, what is happening in the background? We call the same method, so we call the recursion sum for, then we call it for 3 recursively, then we call it for 2 and for 1, and we bump into the base case, so we return 1, because if n is equal to 1, then we return 1. Then we know that the recursive sum 1 is equal to 1, so we can pop another item from the stack, and we come to the conclusion that we have to return 2 plus 1. Then we have to return 3 plus 2 plus 1. Then we return 4 plus 3 plus 2 plus 1. So these method calls and values are stored on the stack. First of all, we keep pushing these method calls to the stack. And if we bump into the base case, then we keep popping these items. So comparing recursive implementation against iterative implementation, we come to the conclusion that recursion is at least twice slower than iterative implementation. Why? Because first we unfold recursive calls, which means that we have to push them on the stack until we reach the base case, this return 1 line, and then we traverse the stack and retrieve all the recursive calls. So that's why it is very elegant sometimes to use recursion, for example, for binary search trees, or just binary search or whatsoever, solving the problem of the Tower of Hanover and so on. But iteration may outperform recursive method calls, and this is very, very important to know. So that's all about the theory. Thanks for watching.